In this lesson, we work out applied problems using the normal distribution. We make use of the Excel functions norm.dist and norm.inv for calculations. We also introduce the standard normal distribution, which is a special form of the normal distribution. We will use this lesson to get more acquainted with applying the normal distribution to some applications. We will work out some problems where we need to apply the norm.dist and the norm.inv functions. We begin by the problem faced by a fast food restaurant that sells falafel sandwiches. On a typical weekday, the demand for those sandwiches can be approximated by a normal distribution with a mean of 313 sandwiches and a standard deviation of 57 sandwiches. The restaurant wishes to find out the probability that on a particular day the demand for falafel sandwiches is less than 300 sandwiches. Here the problem says that the demand for sandwiches is being approximated by a normal distribution with mean 313 and standard deviation 57. Further, the random variable of interest is the demand for sandwiches. So, we can write that random variable as demand follows a normal distribution with mean 313 and a standard deviation of 57. Given this, answer to this part of the question simply becomes an application of the norm.dist function. The demand for falafel sandwiches is being approximated by a normal distribution with mean of 313 sandwiches and a standard deviation of 57 sandwiches. Given this, we wish to find out the probability that the demand for sandwiches on a particular day is less than 300, or in other words, we wish to find out the area under a normal distribution to the left of 300. We do this by using the norm.dist command. So, is equal to norm.dist open parenthesis the number to the left of which we wish to calculate the probability, in this case it is 300, comma the mean of the normal distribution 313, comma the standard deviation of the normal distribution 57, comma then the word true, close parenthesis. The answer is 0.4098 probability or 40.98% chance that the demand for falafel sandwiches on a particular day is less than 300. Another question posed by the fast food restaurant: if the restaurant stocks 400 falafel sandwiches for a given day, what is the probability that it will run out of these sandwiches on that particular day? That is, there will be a stock out of sandwiches. The restaurant will run out of sandwiches if the demand that materializes is greater than 400 sandwiches on that day. In other words, the probability that the restaurant runs out of sandwiches is equal to the probability or chance that the demand is greater than 400. This is area to the right of 400 under the normal distribution with mean 313 and standard deviation 57. We calculate this using the is equal to 1 minus and then the norm.dist. Notice why we need to do 1 minus norm.dist is that we wish to calculate area to the right of 400, not left of 400. So 1 minus norm.dist open parenthesis 400, comma the mean 313, comma the standard deviation 57, comma and then the word true, close parenthesis. So the answer is 0.0635 or a 6.35% chance. So this is the probability that the restaurant will run out of falafel sandwiches on a particular day, a chance of 6.35%. Yet another question posed by the same fast food restaurant: how many sandwiches must the restaurant stock to be at least 98% sure of not running out of sandwiches on a given day. The problem can also be stated in terms of find out the number of sandwiches, and let's call it x0, such that the probability that the demand is less than x0 is at least 0.98. So notice in this case we know the probability and we wish to find out the number under the normal distribution to the left of which that probability occurs. So this is an inverse of what a norm.dist does, and we'll be using the norm.inv command for this. So to calculate x0, we do is equal to norm.inv open parenthesis, the probability is 0.98, comma, the mean is 313, standard deviation is 57, close parenthesis. So the answer got as 430.0637. So this is the answer in response of the number of sandwiches such that the demand is less than that number of sandwiches is at least 0.98. So how many sandwiches should the restaurant stock? The answer is 431, because if you round the number 430.0637 to 430, then remember that if the restaurant stocks 430 sandwiches, then probability that demand is less than 430 will drop below 98%. Hence, in this case, when you round the number 430.0637, you need to round it up to the next integer to tell the restaurant how many sandwiches to stock, so that it is at least 98% sure of not running out of sandwiches. Another problem: John can take either of two roads to the airport from his home, road A or road B. Owing to varying traffic conditions, the travel times on the two roads are not fixed. Rather, on a Friday around midday, the travel times across these roads, across these two roads, can be well approximated per normal distributions as follows. Road A, a mean time of 54 minutes with a standard deviation of 3 minutes. Road B, it takes a mean time of 60 minutes with a standard deviation of 10 minutes. Which road should he choose? If on midday Friday he must be at the airport within 50 minutes to pick up his spouse. If he takes road A, the probability of reaching the airport in 50 minutes is equal to norm.dist 50, 54, 3, true, the answer being 0.0912 probability. If he takes road B, the probability of reaching the airport in 50 minutes is equal to norm.dist 50, 60, 10, true, the answer being 0.1586 probability. So there is a greater probability of making it in 50 minutes if he takes road B. One last topic before we end this lesson is the standard normal distribution. A standard normal distribution is a normal distribution with mean equal to 0 and standard deviation equal to 1. That is, a normal distribution which has a mean 0 and standard deviation 1, we choose to call as standard normal. This distribution is symmetric about 0, and half the probability, that is 50% of the probability, lies to the left of 0, and the remaining half, the remaining 50%, to the right of 0. An important property relating to the standard normal is that any normal distribution of a random variable can be converted into a standard normal by subtracting the mean value from the random variable and dividing it by the standard deviation. As shown, if uppercase X is a random variable that follows a normal distribution with some mean and some standard deviation, then if we transform this random variable into another random variable, uppercase Z, by subtracting the mean and dividing by the standard deviation, This newly created random variable z follows a standard normal distribution, that is a normal distribution with mean 0 and standard deviation 1. We will see applications of the standard normal in our next course in this specialization.